Hello. In this video, we'll look at how to uh, instantiate an interconnect inside our developed system. So we can connect two Wishbone peripherals to our controller device, the NEORV32. So we'll be using the NPU and the camera controller peripherals demonstrated in the previous videos. So I suggest you go through those videos as well, especially because it will teach you how to create a Lattice project, the constraint, where to find the constraints file, especially for the camera controller, and yeah, general stuff around it. How to run the new RV32, how to run the system at 72 megahertz, for example, using a PLL block. So first, go to this go to the interconnect repository. It will be linked in the description. So just go ahead, download zip. It is. It's extract. So now RTL. This is the interconnect. So we'll go. This is the Lattice projects folder from the previous video. So we'll just copy paste the latest new RV32 camera folder. Control V, and let's call it interconnect. Work. No, just call it diamond. Says now V32 setups main 1, setups main interconnect. Alright. So as you may remember, so right now you have passed in the pins for the camera interface and such, and so nothing needs to be done to this file specifically, but we'll need to modify the template file, the processor template file, which only instantiates the camera controller for now. So we need to instantiate the NPU, and we'll need to instantiate an interconnect as well. So I'll be right back. I'll just copy paste those values and be back. So yeah, before I paste in the files, I'll just show you how we can import the interconnect. So it's like add existing file, downloads the interconnect RTL. Remember, we want to copy this file into the implementation sources directory and connect added. Now again, I use components for reference. It's not needed. You can do direct entity instantiation. For example, that's how we do it in the ECP5 EVN top level. So I just declare the new RV32 entity, but I like declaring components for reference for like pin directions and nothing else. Alright, so yeah, I'll now copy paste the pins in and we can move forward from there. Hi, so I have pasted in the pins. Again, this file can be found in the repo. For example, if you like, so for all of the videos in this series, just go to FPGA setup, and depending on your board you can find the files there. So in FPGA setup right now, it's only for the ECP5U5MG 85F evaluation board, but if any are, you can find those files here for any board under FPGA setup through any of the repository. Alright, now going back, so the concept of the interconnect is simple. It's just like the original X-bus pins from the new RV32 are now passed into the interconnect, and the interconnect has two sets of pins, the same interface, one for peripheral 0 slave 0 and one for peripheral 1 slave 1. And so we just have gone ahead and we have just went ahead and instantiated the two peripherals, so the NPU and the WB-OV5640. Now since this was from the old camera project, I'll need to import in the NPU files. So just go back to input files, add existing file, yeah, let's go to this work implementation one source. Here's the files, control A. We want to copy this file into a new project, so we'll select that, add, . Oh well, no. Oh yeah, oh I added them already. Oh well, anyways, the warning's gone and we have everything. Control has no warning, so we can try to generate a bit stream now. Does it seem to be any errors? Yeah, I'll come back after this is done. Okay, so the bitstream could be was generated successfully. So now we can go ahead and program the because the bitstream doesn't match. So now we'll just go inside the correct folder, interconnect, work, implementation, bitstream. Sorry, I forgot to open a GTK terminal. Oh, it's right here. Configuration CRL. So yeah, we were able to upload the bitstream. Now this contains of course the higher IMM and DMM, and it also contains the implementation for the NPO and the camera controller. We look at so this these three playlists cover how to connect the how to run the NEORV32 at 72 megahertz, how to connect the NPU to it, how to connect the camera controller for the OV5640 to it, and how to use an interconnect and connect both the camera controller and the NPU to the NEORV32 simultaneously. I also looked it up for increasing IMM and DMM. And this was most of this was done in Lattice Diamond, but these techniques are transferable to this. These techniques are transferable to different platforms such as Vivado, and of course, depending on your FPGA board, you may need to change the size of your word arrays and such. But of course, it's just like okay, we're learning the techniques here, and those the constraints, the problems will be like we'll go over those in another video, like what will change, of course, along with the new RV32 version, what breaks as such. And yeah, so the next playlist will focus on how to train a model in Python and how to deploy your ADA programs on the new RV32 plus NPU plus camera system along with a video demo if necessary. Thank you.